Hey Algebra, this is a video going over what class did for week 7 on Monday and Tuesday. I'm going to go over the PowerPoint and we're going to make a video where we go through what we did in class for those of you who weren't able to make it. So we're starting a new unit today, Unit 2, and Unit 2 is all about lines. So the title of today's slide is Linear Equations with Two Variables. That just means that they're equations that make lines and they have two variables usually represented by x and y. If you are in physical science or had it last semester, x and y can also represent the independent variable and the dependent variable. As long as something makes a line and has x and y, or two letters, it is a linear equation with two variables. So there's two things I'd like you to be able to do after this video. The first is identify a linear equation. You can look at an equation and see if it's a line or not. And the second is being able to graph one by plugging in numbers. So linear equations are one of the most common kind of relationships that are formed by real-world situations. So there's three here that are examples of linear equations. Number one is how many miles can you drive before your car is empty, runs out of gas. That is a linear relationship, and you can use that to figure out how far can you go. The second one is how long will I have to save before I'm able to buy an item? So I have, $40 and can save 10 more each week. How long until I can afford something that's $100? You can also solve that with a linear equation. The last one is a question I get asked all the time during normal school years is what grade do I need to get on the test in order to get an A in the class? So let's talk about the first objective. How do you know if something's a line or not? Don't get confused by the equation. There are a couple key characteristics. First of all is that the exponent to each variable is 1. That means nothing is squared, nothing is cubed, there's no weird exponents. If it's 1, you don't have to write them, and that's what this equation shows, no exponents. The second one is the variables are added or subtracted. So in this case, A, B, and C all represent numbers that you can plug in, but X and Y are added or subtracted from each other. They're not multiplied or divided. The third point says A or B can be 0, meaning the coefficient number in front of them can be 0, so you would not see it. So if this y term was gone and you just have, x equals a number, is that a line? Yeah. And so is if you just have y equals a number. It's still a line if it doesn't have x or y, one of the variables. Second to last one is there's no radicals, no square root. And the last one is every linear equation graphs as a line. So let's look at some examples of linear equations. Here we go, 2x plus 4y equals 8. So exponents are all 1. Nothing's squared, nothing is cubed. And our variables, x and y, are added together. Number 2, or the second one, nothing here is squared, nothing is cubed, there's no square roots, no radical signs, and everything is added or subtracted, so that's good too. This third one, x equals 1, well, yeah, y, it could be 0y somewhere in the equation, so y is not part of what we graph. X equals 1 is also a line, that works. And the last one is negative 1/2 a plus b equals 5. In this one, your variables are labeled A and B instead of X and Y, but nothing is squared, nothing is cubed, there's no radical, so that's also going to graph to a line. Some non-examples are right here. This first one is not a line because X is squared. The second one, it has a radical, this division sign. So that is not a line either. Those are going to be curves when you graph them, and that is an Algebra 2 subject. This third one, we have our two variables multiplied times each other. So it's not going to be that, also not a line. And then this last one, our variables are divided from by each other. So not that one. Let's go to the other view. So now I've got some questions for you. I have a question for you guys, and it is asking you to figure out which of these are linear equations. Pause the video, take a second, figure out which ones you think would be lines. All right, so let's talk about which one of these are going to be lines. The first one is nothing's squared, nothing's cubed, all added or subtracted. So is C and E. So B is not a line, and that's because X is squared. D is not a line because there is a radical symbol that you're taking the square root of X. All right, so now let's talk about how you graph lines. Let's review how to graph a point first. When you get a point, it'll be given to you like this, two parentheses, two numbers separated by a comma. This is called a coordinate pair. Coordinate means where, like a location. So that pair tells you where on the graph you are going to put that point. The first one is the X value. X goes back and forth. If it is negative, you go to the left, and if it's positive, you go to the right. The second number is our Y value, and Y tells us how far up or down. So in order to graph this point, 1, 3, I'm going to go over 1 in the positive direction, and then up 3, and then I'm going to plot my point, or draw my point. The way I remember which one's X and which one's Y is that the shape X to me has 2 feet, so it needs to be on the solid ground, on the horizontal axis, and then Y kind of looks like somebody with climbing gear going up and down a cliff. There are multiple ways to remember. As long as you know back and forth, then up and down, you're good. So now I have some practice for you. Take a second, plot these 4 points. People who were in class could do it with all the different colors down here, but just try to plot these 4 points, figure out where they would be. Stop the video, and when you're done, start it again and I'll show you the answers. Alright, so I would do this. Let's do one in red. So 3, 4 means I go over 1, 2, 3, and then up 1, 2, 3, 4. You plot the point. The second one I'm going to do is 1, -5 in green. So over 1 and down 5 puts me here. The third point, oh, I'm doing yellow. I have yellow already. So, oh no. Okay. So our third point is -4, 2. So I'm going to go over 1, 2, 3, 4 to the left, -4, and then up 2. So that would make it right there. And then the last point is 0, -3 in yellow. So 0 means you stay at the center, and -3 means you go down. So right here. And if your graph didn't look like it, that's okay. This is the very first time we're practicing this, and if you have a point that doesn't match up, take a second to think about why. Alright, here's the answer key I showed in class. Alright, and then the second part of what we're doing is how to graph linear equations. So we're going to start by doing the 3-point method for graphing a line. First step is you're going to choose 3 values for X, and you can pick any numbers. I usually pick, 1, 2, or 3, or 0, and 2, and 4. You can also pick negative values as long as they stay on the area you have to graph in. So we're going to start by practicing this equation, y equals x plus 3. And I'm going to choose 1, 2, and 3 for my points. So step 2, you're going to make a table and you're going to find the corresponding y values. So I have y equals x plus 3, and if I put a 1 in for x, that makes my equation 1 plus 3 equals y. So when I solve that by adding, I get y equals 4. When I solve for x equals 2, everywhere there's an x, I put a 2 in my equation, and that makes my equation 2 plus 3 equals y. That means y is 5. So if x equals 2, y equals 5, you can do that again for 3, and you'll get y equals 6. So first step is choose some x values. Second step is make a table. Our third step is we are going to graph these points. So my first point is going to be 1, 4. So I go over 1 and up 4 and plot my point like I did here. I also did the second value, 2, 5 in green and 3, 6 in yellow. My final step is going to be to connect my lines, or connect my point with a line. A line has an arrow on both ends, because the line keeps going in both directions. If x equals 100, y is going to equal 103. Same with the negative values. All right, so let's practice graphing. We have y equals x minus 6. So take a second, pause the video if you need to, and on a piece of graph paper or on a piece of line paper you've made some ticks on the axis of and turned into graph paper. Take a second and try to pick 3 points and graph this equation. So the answer to y equals x minus 6, I picked 1, 2, and 3 as my x values. If I put in 1 for x, I get 1 minus 6 equals y. That gives me negative 5. I did the same for 2 and 3, and I got these 3 points, which I graphed on my coordinate plane. I then connected them with a line that keeps going in both directions. Let's look at one more. Let's look at y equals negative 1/2 x minus 4. Just because there's a fraction there doesn't change anything that you have to do. So if you wanted to use 1, we could solve for 1. So we have y equals, oh no, this is not good. Let me try to do it with my computer touchscreen and it skipped. So let me try again. Alright, so if x equals 1, that means this whole first term becomes negative 1/2. So negative 1/2, and then minus 4. So if we solve that, we get y equals negative 4 and 1/2. Okay, so when x equals 1, y equals negative 4 and 1/2. So you go down and you put a point between 4 and 5. You can also use 0. So if x equals 0, this whole first term equals 0, because anything times 0 is 0. So 0 minus 4 gives you negative 4. So at 0, x is negative 4. Plot a third point. If you plot 2, it'll end up right here. And then you connect them. And don't forget to use arrows. Alright, so that is the video for part 1 of this week. If you have any questions about the problems, email me. The first problem on the weekly assignment has a fraction at the beginning, and it freaked out a lot of people in class. You work it the same way you do here. If you want to put in 0 or 1 and then just plot your fractional points, you'll do great. If you have any questions, email me. Yeah, and I will make another video for Thursday and Friday's class in case you can't make it. Have a good week, guys. Bye.